Hey everybody, Mr. Piercy here. What I'm going to be talking about today in this video is demonstrating concepts that we're talking about with parallel lines that are cut with a transversal line. So we're this is just supposed to be a companion to go along with that to show why those conjectures work the way they do. So I'm going to begin with well, really quick before we get going too much on this, you do need some tools for what we're going to be working with. You need a straight edge, you need a compass, pencil, obviously, and for this one, I'm also going to use a piece of patty paper, otherwise known as tracing paper. So all you'll need is just something that you can, kind of see through. The reason why we like to use it, let me move this other stuff out of the way, is because it's pretty transparent. You can use it to look at some things through it. So I'm going to start by making let me make sure we can see all this stuff here. I'm going to start by making a line. Just make a line segment. The length is irrelevant. And what we want to do is I'm going to just do a quick, let me make that a little darker here. I'm going to make a quick construction for parallel lines. So I want something that will be parallel here. So we can also use that as our transversal line now. So what I'm going to do is copy a set of parallel lines. Now, when you're doing this, you don't, if you're trying to do this at school or at home just to go through the process of the experimentation, you don't have to actually do this construction. You could just take something that you know where the lines are parallel. You could even just use your notebook paper. So here we have a set of parallel lines that I've constructed. So let me just extend this out a little bit here and extend this out a little bit here. Here we go. Now that looks a little bit more like what you might see in your textbooks or any kind of diagram online. So I'm going to refer to this as my transversal line. I will call this line A and this line B. So let's go ahead and number these. Now I don't want to number these really typically. Let's call this 1 and I'll put I don't know, 2 here, and then we'll say 3 and 4 and 5, 6, 7, and 8. I'm just trying to be random with how I do these, so that way we don't start associating numbers with having to be in certain places for these types of angles. Now I'm gonna we're not going to use the protractor here for any kind of measuring. The whole point of doing these is the reason that we're getting the patty paper is we're going to use the patty paper with its semi-transparency to help us measure the angles without the use of a protractor. So what I'm going to do is I'm going to simply trace the diagram onto the patty paper. And one more. And again, all this is really designed to do is to just kind of show you, oops, I went off a bit here. Let me clean that up. All I'm really trying to do is just demonstrate why the conjectures we have worked. So let's say I had 1, 4, 5, 8, 6, 2, 7, 3. That's how I number them. Okay? So what we want to know is how do the corresponding angles, how do the alternate interior angles, how do they all work? So let's say my corresponding angles. Well, angle 1 and angle 6, angle 1 and angle 6 are corresponding angles. So what I'm going to do is I'm going to take the patty paper and I'm going to just slide it down and compare where angle 1 and angle 6 sit. And you can see, just visually, you can just see that angle 1 and angle 6 are the exact same thing. They're congruent to each other. So let's try another one. Let's say 8 and 2. I'm sorry, not 8 and 2, 8 and 3. So let's say angle 8 and angle 3. Let's see what we notice here. Okay, so starting here, I'm going to take angle 8 and I'm going to put it where angle 3 is. And same thing, you can see that those angles are identical to each other. So the corresponding angles, what we notice when we do this kind of activity is that corresponding angles with parallel lines they're congruent to each other. And we're going to recognize that with a lot of these angle pairs. So let's take a look at our alternate interior angles. Abbreviate a little bit here. Alternate interior angles. So let's see. Alternate interior angles would be angles like angle 8 and angle 6. So starting here with my patty paper, I'm going to take angle 8, which is right here, and I'm going to put it here in angle 6. Now the way that I have to do that is I have to turn it upside down. So now so you can see the 8 is now going to go where the 6 is. And you can see here again my alternate interior angles, not just the 8 and the 6, but these two angles here also are congruent to each other. So here, again, I will say with parallel lines, they are congruent to each other. Well, what about the alternate exterior angles? So here, let's start over from the original position so everything lines up. So alternate exterior angles are going to be like angles 1 and 3. So let's look at angle 1 and angle 3. That's what I'm going to look at here. So again, because of the way that they're situated, I will have to turn the patty paper, rotate it 180 degrees, so that way now you can see angle 1 and angle 3 are going to occupy the same spot. And you see here, oh hey, those also are congruent to each other. So when I have parallel lines that are crossed with a transversal, we often say cut with a transversal, corresponding angles, alternate interior angles, and alternate exterior angles all wind up being congruent to each other. Well, what about the same side interior angles? So let's take a look at those. Same side. Interior angles. What happens with those when they are when my lines are parallel to each other? So let's take a look at angle 8 and angle 2. Let's see what happens when we compare those two to each other. So let me put my patty paper back in its original starting position. Now, what I'm going to do is I'm going to take this angle 8 here, and I'm going to simply translate the paper down so that it's next to angle 2. Now I know you see the 4 here on the patty paper, but underneath it is the 2 of angle 2 on the just blank paper that I have. And if you notice, angle 2 and angle 8, they form a linear pair. So that means they must be supplementary to each other. And we can see the same thing with this other set of alternate interior or same side interior angles. If I look at 5 and 6, if I take angle 5 and slide it down to where it's next to angle 6, they also form a linear pair, which lets you know that when parallel lines are cut with a transversal, the same side interior angles become supplementary. Oh, and you can't see it. So with our lines, if they are parallel to each other, the transversal that creates these angle pairs will cause corresponding angles, alternate interior angles, and alternate exterior angles to become congruent to each other, but it will also cause these same side interior angles to become supplementary to each other. Now that coupled with the fact that vertical angles are also congruent and these pairs here, there's a lot of information going on here that at first glance you may not recognize, but there's some relationships associated here that you need to understand what they are. And the purpose of this video was simply to show you where those ideas came from. Not just saying, well, hey, take your teacher's word for it because they're the teacher. Why would they lie to you? This is why. This is one of the things that I really like about geometry is that you can always see why something is the way it is. So here is the proof in why these conjectures can be made, saying that these angle pairs are congruent to each other and these angle pairs must be supplementary to each other. So that's going to be it for this lesson, and again, it's just to demonstrate why the conjectures are true. But thanks for watching, everybody, and we'll see you